derive it.
It's not good, though.
No, I don't know.
Actually, they might
Why are
end
you
up
not doing
moving
it then?
What's that?
They might end up moving it because everyone.
It's not hard.
I like
No,
it.
it's not.
It's fun.
Okay, finding the area between two curves. Okay, so we're going to find the area between this curve from 3 to 6. Bless you. Okay, I think I'm going to make you graph like a little bit of visuals on the test. So if you just had a very general vision of what this looked like, what are some things you can tell me about it? Anybody remember? It's a parabola. Specifically, what direction? Okay, down. So that's good enough, but just kind of have a general sense of that. Okay, so how do we set it up? We go the integral from 3 to 6 of this equation with respect to x. So that's the setup that says here's the area. Okay, so now we're going to actually do the integration. Ready? X, I'm going to go up an exponent and then take 8 divided by 2. X squared, I'm going to move up to a cubed, take 3 divided by 3. Okay, so this is all old stuff. Now I'm going to do this with running a 6 through it. And I'm going to do that again, running a 3 through it. Okay, and you always subtract, right? Run a 6 through it, subtract, run a 3 through it. And I'm sure you all want me to just do this. So that is a negative 72. And that is a 9. Okay, so that all comes out to negative 81. Okay, so here's the deal. Area, we probably don't want to say the area is negative 81. So we're just going to say the area is 81 as in whatever you have, you just absolute it. Okay, but why did it mathematically come out negative? Because here's what happened. This area is located below the x-axis, and that's why it's negative. Okay, but we'll say that the area region is 81, but specifically it is just below the x-axis. Okay, so that's why it came out negative. Okay, so just absolute your answer. Okay, so here is where we're going to add on to what we know. Okay, so find the area bounded by that and the x-axis. Okay, so this I know is a parabola, and I know it opens down. I know those things again. But this time, when I'm integrating, I have not been given any numbers. So we're going to have to find our numbers. Okay, so where does this parabola hit the x-axis? So where does it have a y value of 0? Okay, so now how do I solve something that looks like that? Obviously we go all the way back to grade 11. What's our strategies? Factor. So I'm going to GCF. I'm going to take out an x. So at 0 and at positive 6, that's the values. So here's my visual. So from 0 to 6, what's the area? That's what's happening to this. That's what we're doing. Okay, so we can go 0 to 6 now. That's just the new part, and now everything else is old. So what's the area from 0 to 6? Okay, so I'm going to do the antiderivative from 0 to 6. Here we go. Up means it's an x squared. 6 divided by 2 means there's a 3 in the front. If I go up, it's an x cubed. The original 1 divided by 3. Okay, now I know my numbers to plug in, so I'm going to plug in a 6 minus, are you okay if I just write 0? Because if I plug a 0 in, that's what's going to happen. I can see it. And I get 36 as the area. Okay, number 3, do you want to do it or skip it? Because it's just the same thing and I actually gave you the x values. So there'd be nothing new really. And number 4 would be the same as question 2. I would just need to get factored. Number 4 is the exact same as 2. Are we, do you want, I can do them, but are you okay with that question? Okay, so then I will skip to the next one. Find the area between that and that. Okay, so I'm a visual person and I'll show you what this looks like. This is a cubic. And what is 16x? What kind of shape is it going to make? A straight line. Okay, so that is the cubic and that's the line. And we're going to figure out the area that's stuck between them. So that's what I'm actually trying to get. Okay, so what do I want? I want these x values because I want to know the boundaries. Okay, so in other words, I need the intersection. So where does this equal this? So that's what I'm going to try to figure out, the intersection. Okay, so now I'm going back to grade 11 strategies here. If I have two variable types, I'm going to zero it out. I'm going to zero it out. And then I look for factoring. So it's a GCF. Then it's also a difference of squares. And it makes sense on my graph. Right? That's where they intersected, right? At -4, at 0, and at +4. Okay. Now I also am going to do this. I could do this area and this area, but does this visually make sense that this area should equal that area? Can you see why it's the same on both sides? So I'm actually just going to do one side and then I'm just going to times my answer by 2. I could do them separate and that's okay too. Okay, so what to you, if I zoom in, I'm going to do this section. What makes sense? The area under the line, subtract the area under the curve, or the area under the curve, subtract the area under the line? I think if I zoom in on this, the area under the line would be like that. And if I subtract the area under the curve, I would end up with that. Okay, so I'm going to show you two ways and you can pick which way. Alright, so the area under the line from 0 to 4, so that's that, and the area under the curve now, specifically for area, it would have worked to just chunk them into one. You could have done this. You could have just done that, and that would work. If you make sure you're doing this properly, if I had subtract and then like a binomial, I would have to make sure I distribute my negative sign. So there could be some errors if you're grouping it together, versus here, you won't make those errors. So, doesn't matter. Okay, ready? We're going to integrate. So now we go up, so x squared, we needed 8. Up, we need a 4. So now we need a 4th in the front. And again, if you had done it this way, you can keep going that way, that's fine. Okay, 8 times 4 squared, subtract 0, right, when I plug in the 0. And then here, plug in a 4, plug in a 0. So doing the same thing, except for we're just combining two things together. So this is 128 minus 64. So that is 64. So this area, there's 64 units. Like think about your graphing grid, there's 64 in there. And this should also be 64. So the total area should be 128. Okay, here's something to be aware of. What if I had just accidentally done this in the wrong order? What if I had taken the area under the curve, subtract the area under the line? Okay, it would have been fine. It's just that because you did it backwards, your number would have came out negative 64. And that's all good, just make sure you just turn it into a positive, and that would be fine. So if you had done that in the wrong order, that's okay. Okay, find the area between the curve x squared, so have a general sense, and y equals 4x plus 12. So that's a line. So where does the x squared equal 4x plus 12? Where does it equal each other? Okay, so I'm going to 0 it and factor it. So 6 times 2 Okay, so I am going to make you do a little bit of a visual on your test, and I say graph what you're finding. So y equals x squared, you should understand that it's a parabola vertex on the origin. This line, you should understand, has a y-intercept at 12 and a slope of 4, so it would head in that direction. So I'm asking for no details, does this make sense? That's all I want you to graph. Where do they intersect? At -2 and at 6. And I want the area between them. So what makes the most sense? The area under the line subtract the curve, or the curve subtract the line? Looking at this visual, the area under the line is all of that, subtract the area under the curve would get me that. Okay, and again, if you had picked the opposite order, your answer will be negative, just change it. Okay, so the area under the line so now I have those -2 to 6 values. Subtract the area under the curve. Okay, if you wanted to, you could have put it all in one. You could have done that all at once. Okay, I don't recommend it unless you're making sure you're good with your negatives, because if I had done this in the wrong order, this is where people make the mistakes. This is a mistake because you would need that, which creates a that. You see the mistake that would be common? Okay, so if I separate them, I don't even have to think about that mistake. Okay, here you go. Antiderive them. So 2x squared plus 12x you should be getting good at this one. The x squared turns into a third x cubed. I think we've had that one a bunch of times. Okay, so this one's going to be a bunch of stuff going on here. So I'm going to plug in the 6, plug in the -2, okay, so you're going to have to do that, and then same thing over here. Right? You're going to have to do them for both. I think I was getting 160 there. And again, if you had done them in the wrong order, not a big deal. You would have got that as a negative, and then just make sure you change it. Okay, is that okay? There's more examples, one more example, but that's the basics of it. You just figure out where do they equal each other, which gives you your numbers, the -2, the 6 number, and then you subtract.